Hi, I'm Steve Proud, and today I'm going to show you a video, and it's going to be about something that's fantastic, and you're going to learn a lot, and you're going to thank me for everything. Enjoy.
Hello, and today we're going to talk about Festo CECC-LK PLC, and we're going to be using that to communicate I/O link to a Festo sensor, an I/O link sensor. This video can be used for all the sensors pretty much, same concept, just might be a different scaling and so on and so forth for each sensor and for the settings and the pressure or whatever the units that you're using, different scaling. That's basically it. So this is the setup right here. It's not very complex by any means. And let's get into it here. So first thing you want to do is get the IODD files. Go to the Festo website, www.festo.com, go to your country, click on the top support downloads here. Come into here in the search and type in SPAU, and then type in your sensor code, or you can type in the part number, whatever turns your crank, 803, 867, or 803, 6871. Yeah, there we go. So this is the sensor. Oh, actually, we're doing SPAU. Sorry, wrong one. So SPAU, and we're doing a cancel 1212. So this is the sensor that I'm using today. And go to the software tab, and here we have all the different IODD files, and you'll see here that each one of these IODD files is for a certain unit that you want to use. So pick the units you want to use, download them, unzip them, and then we'll get to the next point. The next point is going to be to install the IODD file. So click on device repository, come into here, click on install, and then wherever you've zipped them, pick the file, and then make sure that you've selected I/O link device, otherwise some finicky little thing will happen. You select the file, maybe it'll register it again, I don't know. Go like that, you get the proper installation, close, and you're done. So you've installed the IODD file. Now we've got the intelligence to bring into the PLC here. Then we're going to do a, let's see here, add device, all vendors, IO-Link master. So we're going to add a IO-Link, oh, sorry. So I created this project from scratch, and when I did that, I basically selected a CECC-LK, which is the Festo PLC, and it created this shell of a job here, a shell of a project. And then you bring in this and you add device, add your IO-Link master, and when you click, you see how things are moving around here. So depending on where you click, keep it open, and then we're going to look for our SPAU. And you could, I'm just going to select that, say plug device, and okay. So now we've got that in here. Way you go. That's one way of doing it. I'm going to delete that, hitting the delete button, and I'm going to do another thing here. So in the sensor here, I always put on update IO and stop, and always enable. This is the Service Pack 7 CoDeSys project. So 3.5 Service Pack 7 Patch 2, I think it is. Under communication settings, if you come in here and scan the network and then find your device, set active path. Once you've done that, save it to the project, and when you come over to here now, you can right click and say, hey, scan for devices. So if you've got the EDS files installed, hey, look at that, copy the project, you're done. You don't have to think about which one it is in the list. The way you go, you're up and running, lickety split. And you could theoretically, dump this in right now, yes, yes. And if all you're doing is wanting to get traffic or the process data variable, then you're done. You know, you've got the IO-link mapping, you've got the process data variable, and right now my pressure on my LED display is reading 2.3. But look, it says 261. And what are these 0 to 16,383? Well, those are engineering units because they don't scale it for you, unfortunately. Sorry, I just keep kicking these buttons wrong here. So when you are also at the website, there is an expert knowledge tab. Okay, and there's this file right here. Okay, this application note. When you download this application note, it will show you this right here. Okay, and this document right here talks about all the IO-link parameters, how the process data works. I've marked up mine already a little bit, so pay no attention to the markups because these things are not in there. And you get to a point where you get to section 3.5 or whatever it is here, basically conversion factors for the parameters, process data variable, and then a couple other ones like the set points. So depending on the unit that you have downloaded, in my case, I'm using PSI, and I have a 0 to 10 P10 switch, then you take that process data variable, the engineering value or the raw data that's coming in right here, and you multiply that by the, I'll call it a scaling factor or conversion factor. So I'm going to add that code in a minute, and we're just going to go offline. So the other thing real quick is you've got, go to specialist mode, come into here, you can read this page, and you can read data from the sensor. Why am I not getting anything here? Read the data. I typically, when there's something like this going on, do a create boot. Okay, so what I just did was I rebooted the PLC. I've been doing so many tests with this thing. I think that's what's been the problem. So you can come in here and you read the page, you get all the information. And you can also write the page if you'd like to. Diagnostics. And there you go. So within like a couple seconds or 8 minutes, we've downloaded the IODD file, we've scanned the network, added the device, dumped it into the PLC, and we're getting process data variable. And if you were to take the IO-link mapping and take this current value of the PDA or PDV value, multiply it by the scaling factor, which we discussed right here, and you would get a matching value comparable to the LED display. All right, so I'm going to go offline here, and let's talk about libraries. So there is a library, CECC, and within the library you've got a couple of function blocks here and there. So when it comes to IO-link, there's not a whole lot you really want from the library. Yes, you of course want all the parameters from the sensor. I haven't found a way to do one click of the button like this screen here. When you go in and you do a read, they're doing something backdoor here that seems to get all the values. If you want to get each individual value, you can use the excuse me, the library to get that data. So let's talk about the first thing. All right. So let's add this. And I'm going to bring in some things from another PLC program that I've got offline here. Paste. So I've got variables that I've got added here. And I'm going to delete this. And I'm simply going to bring in my POUs. So to me, this is the basics of what you need in a project, and you can expand on the reading of the parameters. I'm not showing write, I'm just showing reads. It's just a sensor. So the first thing you want to do from a standpoint is you want to make sure that the device itself is connected. So there is this get mode right here, this get mode, and this function block, and you basically give it a port number 0 through 3, and it will tell you the status of the port, because it could be a standard port or a IO-Link port, and tells you whether the sensor is connected or not. All right, so the next thing that might be of interest is the validation type, and all of these are also discussed in detail in this book right here, and the one that we downloaded earlier. Talks about all the different parameters and what they are, the units, and so on and so forth. The again, this is port-based, so port mode, and then the E mode is there's 3 different validation types. There's a 0, which is no validation at all, so you just plug in any sensor to the port, and it won't care about whether it's vendor or device ID or serial number match. And then 1 types in like written here, so you need to have a proper vendor ID and device ID, which you input right here and here. And then the third one adds a serial number, which you would input here. I never use the serial number, I'm just doing the vendor and ID. And if you go to your identification page, you've got vendor ID, device ID, and you've also got the vendor ID here and here, and the device ID. So I've had times where this device ID here does not match this one here. So that may be something to consider looking down the road. But basically, I've got a 333 and a 122. And because this is observed on startup, basically once you've downloaded this and created a boot project, you need to cycle power the PLC, and only then will it monitor everything. Okay, so the next thing is communication status. Perhaps somebody is interested in counters. I've done counters for all ports, even though I'm using the 1. Then in the previous part of the video, I talked about process data. So this raw data here. So this right here is PDV. That's the input. That's the raw data from 0.16.383. I showed you that needed to be multiplied by a conversion factor. So I have this global variable right here, and I've said, okay, the raw data is coming in at this input. I've got the conversion factor of this in order to get the proper units, and you'll have your output and so on and so forth. So in this area right here, conversion factor, raw data multiplied by each other gives you your value in PSI. And I've taken part of the the actual document here, and I've just taken one line right here from the document and shoved it into the PLC code here. I've said that you're running under PSI on this particular sample, and verifying that the device is connected to the port before we get the data. And then we have what most people will be interested in is reading and writing of data. So there's a read parameter data. This particular one here, again, if you look in the manuals, I'm doing a pressure monitor output sensor, getting the data, multiplying it by the scaling factor, a couple of conversions. This one over here, you can execute this at runtime and put in whatever values you want. And the flashers is the timer I have going in the code here. So every 400 milliseconds, it's going to execute the code and read the parameters. Talking about parameters, I've just changed the video a little bit here, and I've changed what I execute the parameters with. I'm using this tag here, parameter read. I was at one point using a timer that I had off of this code right here, but some sensors, when you do a read or write, they will actually change screens back to the main menu. So, for example, if you've got a timer that's set to read parameters every 2 milliseconds, and you're trying to look at something on the LED display, and what's going to happen is the sensor will continuously be put back to the main screen. So you're going to try and navigate to a different screen, and every 2 milliseconds or 2 seconds, it's going to put it back to its main screen. So you're going to be scratching your head saying, what's going on with the sensor? There's something wrong. But in fact, there's nothing wrong. It's just the fact that you're reading parameters or writing parameters. So whenever you're doing a read or write, some sensors out there that are IO link will actually revert their screen back to the main screen. In my case, I've got a visualization here, and I just added a push button right here, and that push button will act on the this tag right here. And same thing right here, parameter read. Main task as well. It's just calling the other routines here. This task over here, we've got a priority of 1, which is a real-time task, 10 milliseconds, calling the main's calling the rest of the routines there. So again, we have gone into here, we've set up our gateway, pointing at our PLC, do a download, yes. I will create the boot project, and then I'm just going to go offline and do a restart of the PLC real quick. Okay, so I restarted the PLC and we're online, and the timer's going off and on. Connection status. So as I said before, the get mode gives you an IO link. So let's see if we can zoom in a little bit for you. So we get, let's just turn that right off here. Turn this right off. So you get a device connected status, and you get IO link mode is the operation. Validation. Validation type is compatible, and those are the numbers. If these were not actually validated, then the sensor would not be connected. So just to show you that, I'm going to quickly disconnect one sensor. You see here how we've got the triangle, the orange triangle right now. If you go to the connection status, we're false right now. And now I'm going to plug in another SPAU, but it is a slightly different model. So instead of it being a 122, it's actually I think it's a 109. You can't read the page because there's nothing to read because it thinks, so actually it's a 109. So there you go. So if I do a read, it's a 109 instead of a 122. And it says not running. So by that, the connection status tells all. Unplug it, plug it back in, and immediately it goes green. Hooray. Validation. Okay, communication status. You see the counters counting up. So we've got this one here. Retries, aborts, comm cycle, and process data. So this number right here, 2 point whatever. So we're actually we're fluctuating back and forth to. So let's just go with we're on our LED display. We've got 4.2 and we were 4.22. There's 2 decimal points here. So that works perfectly fine. And then talk about the parameters. So let's just close all the windows here. Excuse me. So we've got 2 programs here. And we've got a watch window. And right now the PLC is just been started up from scratch. The code that I'm using here is slightly modified than the offline stuff that I showed recently in the video. It's just so that the read parameters are only executed when I execute the visualization. So as you can see here, put this out of the way somehow. Okay, so I've got this one down here, right here, and then I have the set point right there, and you can add stuff really simple just by, do that, drag it, this one here, drag it, so on and so forth. There's your watch window, and as soon as I do this, this is a toggle, so I'll turn it on, and now we get the values here. So what that is discussing is, all right, this is the document that we had opened earlier. So these highlighted items here are what I'm reading with the parameters, and they're unsigned integers. And let's just make a change now. So turn this off so that it's now false. Now it's not reading that anymore. Again, I'm toggling this and not doing this consistently and over again because the resources in memory on some switches is not large enough. So what happens is if you continuously read or write parameters, the LED display will continuously revert back to the main screen. So if you're a user and you're physically trying to change something on the machine, you won't be able to. All right, so what I've done here is I've changed output B to 90.2. And all right, so I finally changed it from 87 to 90.2. I'll change it again. And we'll go back down to, we'll go to 88. And you'll see here that it's reflected there, 88. Likewise, you can go to the sensor here and, observer. You can expand these here, do a read. There's your 88 right there. So that just gives you an idea about how to read parameters using the function blocks. The This particular one here is in structured text, and based on the manual here, you'll have to, of course, convert it based upon what the manual indicates as being the defaults and so on and so forth. In this case, I'm using the conversion factor again, and also converting it from a byte array to an unsigned integer. The code here does the exact same thing except with structured text. Let's talk about one other thing. So I guess one of the advantages of IO-Link is that on power up, whatever device you throw in there, it'll just get overwritten by the parameter set that you have already stored. So in the master here, I see here that there is a thing. So I'm offline right now. So you pick the port, and for some reason they don't like to pick ports. You know, some ports are 0 through 3, some are 1 through 4. But there is only 4 ports in this PLC. So this port 1 should match up port 0 throughout the rest of the code. You pick a validation type. Again, I'm using the same one here. If I do a read of port 1, it gives me this serial number. And if you click on download to start, it'll tell you, it'll give you a fault. Yeah, you got to read it first. So basically, you store this. It does this checksum, go like this. So the idea here is that now when you download and create the boot project and whatnot, that at startup, it'll download the parameters to the device, and everything will be working. So if you replace the switch, you don't have to worry about going and configuring it all over again. It'll automatically do that for you.